Chapter 10: Understanding Elementary Shapes. In our daily life, we come across different objects having different shapes. All these objects are formed using curves or lines. Most of them have corners, edges and planes. They have different sizes and measures. We compare their shapes with the line segments, angles, triangles, polygons and circles. In this chapter, we shall develop tools to compare their sizes. Line segment. A line segment is a part of a line. It has two endpoints and has a definite length, no breadth and no thickness. A line is drawn with arrows on both its ends because it can be extended in both directions. Consider a line make 2 points P and Q on it. The portion of the line with endpoints P and Q is called the line segment PQ. It is represented as PQ. A line segment is named using capital letters. Generally, a line segment has a definite length, whereas a line does not have a definite length. Look at the figures given below carefully. How many line segments do you observe in each figure? Measuring line segments. The measure of each line segment is called its length. To measure line segments, we use a scale that has meters, centimeters, millimeters, etc. The most commonly used tool is a ruler or scale. It is either 12 inches long, 30 centimeters or 6 inches long, 15 centimeters. The methods that compare the length of line segment are as follows. First, comparison by observation. By comparison of two line segments, we understand to know relation between their length, that mean which of them is longer or shorter. Suppose we are given two line segments PQ and RS. By just looking at the two line segments carefully, we can say that the line segment PQ is longer than RS, but we cannot always be sure about our usual judgment. For example, look at the adjoining segments. The difference in length between two segments may not be clear. We need some other method to compare the length of segments in such situations. In the adjacent figure, PQ and RS have the same length. It is not quite clear. Second, comparison by tracing. To compare line segment PQ and RS by tracing method, trace one of the line segments RS on a tracing paper and place it along PQ in such a way that point R of traced segments RS coincides with the point P of the line segments PQ. By doing so, we observe the following conditions. P, R is Q, S lies between P and Q so that RS is less than PQ. First statement, R lies on P and S lies on Q so that PQ is equals to RS. Second statement, S lies beyond Q so that RS is greater than PQ. Third statement, this method of comparing length of line segment is not practical as we cannot trace the length every time you want to compare them. Third, comparison using ruler and a divider. The picture of a ruler and a divider are shown below. Millimeter, centimeter, ruler, inch, divider. Ruler. To measure line segment, the most commonly used tool is a ruler. It is marked in centimeter or inches or both. We use a scale or ruler that has centimeter marks on edge and inch mark on the other edge. Observe that each centimeter is divided into 10 equal parts and each part is called a millimeter. mm. Relationship between meter, decameter, centimeter and millimeter. 10 millimeter equals to 1 centimeter. 10 centimeter is equals to 1 decimeter. 10 decimeter is equals to 1 meter. Measuring line segments with a ruler. Step 1. Draw a line segment and mark the endpoints P and Q. P, Q, 5 centimeter. Step 2. Place the 0 centimeter mark on the ruler at point P and mark 5 coincides with point Q of the line segment PQ. Hence, we say length of PQ is equals to 5 centimeter. If the corner of a scale is broken or 0 mark is faded, we measure from mark 1 and subtract 1 centimeter from the reading corresponding to the end point of the line segment on the scale or ruler. There are chances for errors even in this procedure. The thickness of the ruler may cause difficulties in reading of the marks on it. This problem can be avoided by using a divider. Divider. In geometry box, there is an instrument called divider. A divider has two arms hanging together. Each arm has a pointed metallic end. The distance between the two ends can be increased or decreased as required. Measuring line segments with divider. There are following steps to measure a line segment using divider. Step 1. Open the divider and place one end on P and the other end on Q. Step 2. Without disturbing the distance between the two ends, place the divider on the ruler in such a manner that one end falls on the 0 mark. Note the point on which the other end falls. If it shows 4 cm, then the length of the line PQ you have drawn is 4 cm. Exercise 10.1. Question 1. Draw line segments for the following measurements using ruler. A. 5.8 cm, B. 3.6 cm, C. 4.4 cm, D. 7.2 cm, E. 5 inch, F. 2.5 inch, G. 3.5 inch, H inch. Question 2. Compare AB and CD by tracing. Question 3. What do you mean by line segment? Solution. A line segment is a part of a line. It has two endpoints and a definite length. Question 4. How many line segments can you find in the following figure? Write them. Solution. First, AB, BC, AC, AD, AE, BE, BD, ED, CD. Second, AB, BC, CD, DE, EF, FA. Third, AB, AE, AF, AC, BC, BF, BD, CE, CD, FE, FD, DE. Fourth, OP, OQ, OR, PR, PQ, QR, OD, OC, OB, OA, DC, DB, DA, CB, CA, BA. Fifth, AB, AC, BC, PQ, PR, QR. Question 5. Why is it better to use a divider than a ruler while measuring the length of a line segment? Solution. The thickness of a ruler may cause difficulties in reading of the marks on it. This problem can be avoided by using a divider. Question 6. Fill in the blanks. A. 1 cm is equals to 10 mm. B. 1 meter is equals to 10 decimeter. C. In a ruler, each centimeter is divided into 10 subparts. D. 1 decimeter is equals to 10 centimeter. Question 7. If B is the midpoint of AC and C is the midpoint of BD, where A, B, C, D lie on a straight line, say why AB is equals to CD. Angles, right and straight. You know that there are 4 main directions. They are north, south, east and west. The 4 directions have been shown in the figure. Do you know which direction is opposite to north? Which direction is opposite to west? Just recall what you have learnt about directions earlier. We would use this knowledge to study a few properties about angles. East, west, north, south. Let us discuss with an example. Stand facing towards north. Turn clockwise to east. We say you have turned through a right angle. A right angle is equals to 90 degree. Follow this by a right angle turn. Clockwise, now you face south. If you turn by a right angle in the anti-clock direction, which direction will you face? It is east again. Why? Now study the following positions. You stand facing north. By a right angle turn clockwise, now you face east. by another right angle turn clockwise for finally face south. From facing north to facing south, you have turned by 2 right angles. It is same as a single turn by 2 right angles. The turn from north to east is by a right angle. The turn from north to south is by 2 right angles. It is called straight angle. North-south is a straight line. A straight angle is equal to 2 right angles is equals to 180 degree. Stand facing south. Turn by a straight angle. In this situation, you would be facing north. To turn from north to south, you took a 2 right angle turn. Again, to turn from south to north, you took another 2 right angle turn in the same direction. Thus, turning by 2 right angles, you reach your original position. By how many right angles should one turn in the same direction to reach his/her original position? Turning by 2 right angles or 4 right angles in the same direction makes a full turn. This one complete turn is called 1 revolution. The angle for 1 revolution is a complete angle. A complete angle is equal to 4 right angles is equals to 360 degree. Such revolutions on clock faces. When the hand of a clock moves from one position to another, it turns through an angle. Suppose the hand of clock starts at 12, then in making 1 revolution, it goes round until it reaches as 12 again. Consider these examples. From 12 to 3, 1/4 of a revolution or 1 right angle. From 12 to 9, 3/4 of a revolution or 3 right angles. From 12 to 6, 1/2 of a revolution or 2 right angles. Example 1. Where will the hour hand of a clock stop if it A. starts at 3 and makes 3/4 of a revolution, B. starts as 12 and makes 1/4 of a revolution, C. starts as 12 and makes 1/2 of a revolution? Solution. A. In 3/4 of a revolution, it will rotate by 270 degree, 360 into 3/4, and hence it will stop at 12. B. 1/4 of a revolution, it will rotate by 90 degree, 360 into 1/4, and hence it will stop at 3. C. 1/2 of a revolution, it will rotate by 180 degree, 360 into 1/2, and hence it will stop at 6. Example 2. What fraction of a clockwise revolution does the hour hand of a clock turn through when it goes from A. 69, B. 3 to 12, C. 9 to 3. Solution. We observe that in one complete revolution, the hour hand rotates by 360 degree. A. When the hour hand goes from 6 to 9, it will rotate by 1 right angle. Fraction is equals to 90/360 is equals to 1/4. B. When the hour hand goes from 3 to 12, it will rotate by 3 right angles. Fraction is equals to 3 into 90/360 is equals to 3/4. C. When the hour hand goes from 9 to 3, it will rotate by 2 right angles. Fraction is equals to 2 into 90/360 is equals to 1/2. Exercise 10.2. Question 1. What fraction of a complete revolution have you turned through if you stand facing A. south and turn clockwise to west? Solution. 1/4. B. west and turn anti-clockwise to east. Solution. 1/2. C. south and turn anti-clockwise to north. 1/2. Question 2. How many right angles have you turned through if you stand facing A. south and turn clockwise to face north? Solution. 2 right angles. B. north and turn anti-clockwise to face west. Solution. 1 right angle. C. east and turn anti-clockwise to face west. Solution. 2 right angles. Question 3. What rotation is needed to turn A. from north to south in a clockwise direction? Solution. 180 degree. B. from south to east in an anti-clockwise direction. Solution. 90 degree. C. from east to west in a clockwise direction. Solution 180 degree. Question 4. Where will the hour hand of a clock stop if it A. starts at 3 and makes 3/4 of a revolution anti-clockwise? Solution. Stop at 6. B. starts at 6 and makes 1/2 of a revolution clockwise. Solution. Stop at 12. C. starts at 9 and makes 1/4 of revolution anti-clockwise. Solution. Stop at 6. Question 5. Find the number of right angles turned through by the hour hand of a clock when it goes from A. 6 to 9. Solution 1 right angle. B. 9 to 12. Solution 1 right angle. C. 3 to 6. Solution 1 right angle. D. 12 to 6. Solution 2 right angles. Question 6. Where will the hour hand of a clock stop if it starts A. from A and turns through 2 right angles? Solution. Stop at 1. B. from 10 and turns through 3 right angles. Solution. Stop at 7. C. from 6 and turns through 1 right angle. Solution. Stop at 9. Acute, obtuse and reflex angles. Till now we are aware of a right angle and a straight angle, and angles are formed when 2 rays meet at a point. The 2 rays are called the arms of an angle. Different angles are formed by the rotation of a ray. Generally, measure of a right angle is 90 degree, and that the measure of 2 right angles or a straight angle is 180 degree. However, not all the angles we come across are one of these 2 kinds. The angle made by a ladder with the wall or with the floor is neither a right angle nor a straight angle. Magnitude of an angle does not depend upon the length of its arm. The angle made by a ladder with the wall or floor is less than a right angle. Let us know what the acute, obtuse and reflex angles are. First, acute angle. An angle whose measure is more than 0 degree but less than 90 degrees is called acute angle. An acute angle is less than 1/4 of a revolution. Second, obtuse angle. An angle whose measure is more than 90 degree but less than 180 degrees is called obtuse angle. An obtuse angle is greater than 1/4 of a revolution but less than half a revolution. Third, reflex angle. The angles which have measure more than 180 degree but less than 360 degrees is called reflex angle. There are following acute angles shown in the figure. There are following obtuse angles shown in the figure. There are following reflex angles shown in the figure. Exercise 10.3. Question 1. Give 2 examples from the environment for each one of the following. A. Right angle. B. Obtuse angles. C. Reflex angles. Second, classify the following angles as acute, obtuse and reflex angle. A. 35 degree. Solution. Acute angle. B. 325 degree. Solution. Reflex angle. C. 120 degree. Solution. Obtuse angle. D. 45 degree. Solution. Acute angle. E. 150 degree. Solution. Obtuse angle. F. 200 degree. Solution. Reflex angle. G. 145 degree. Solution. Obtuse angle. H. 220 degree. Solution. Reflex angle. I. 21 degree. Solution. Acute angle. J. 135 degree. Solution. Obtuse angle. Question 3. Without measuring, find out what kind of angle is each one of the following. Solution. A. Acute angle. B. Right angle. C. Acute angle. D. Acute angle. E. Obtuse angle. F. Straight angle. Question 4. Look at the figure and name the following. A. 4 right angles. Solution. Angle AOC, angle BOD, angle COE, angle DOF. B. 4 acute angles. Solution. Angle AOB, angle BOC, angle COD, angle DOE. C. 4 straight angles. Solution: angle AOE, angle BOF, angle COG, angle DOH. D. 4 obtuse angles. Solution: angle AOD, angle BOE, angle COF, angle DOG. E. 4 reflex angles. Solution: angle AOF, angle BOG, angle COH, angle DOA. Question 5. Match columns A with column B. Column A, column B. First, obtuse angle to F between 1/4 and 1/2 of a revolution. Second, straight angle to B, half of a revolution. Third, right angle to E, 1/4 of a revolution. Fourth, reflex angle to D, more than half a revolution. Fifth, acute angle to C, less than 1/4 of a revolution. Sixth, complete rotation. 2A. Rotation of 4 right angles in either direction. Measuring angles. D-scale protector. We were able to measure angles. Now we used for measure to the angles like acute, obtuse or reflex. We can easily found with a D-scale or protector. The measure of angle. The measure of an angle is called degree measure. One complete revolution is divided into 360 equal parts. Each part is a degree which is denoted as degree. We write 360 degree to say 360 degrees. The protector. Angles can be measured using a protector. A protector is a geometrical instrument that looks like a letter D. You can find a protector in your geometry box. The curved edge is divided into 180 equal parts. Each part is equal to a degree. The angles are marked from 0 degree to 180 degree on the edge in clockwise direction as well as in anti-clockwise direction. O is the midpoint in the base line of the protector. Let us measure angle ABC. 1. Place the protector in such a way that midpoint O of the base line coincides with B and baseline exactly overlaps on the line segment BC. Second, adjust the protector so that it is along the straight edge of the protector. Third, there are 2 scales on the protector. Read that scale which has the mark coinciding with the straight edge with ray BC. Fourth, the mark shown by BA on the curved edges given the degrees measure of the angle. We write M, angle ABC equals to 40 degree or simply angle ABC equals to 40 degree. Exercise 10.4. Question 1. With the help of a protector, measure the following angles. Question 2. Measure and classify each angle using protector. Angle, measure, type. A. Angle MON. B. Angle MOP. C. Angle NOP. D. Angle QOP. E. Angle QOM. F. Angle QON. Question 3. Measure the unknown angles A and B in degrees. Question 4. Write T for true and F for false for the following statements. A. The measure of an obtuse angle is less than 90 degree. Solution. False. B. The measure of one complete revolution is equals to 180 degree. Solution. False. C. The measure of a reflex angle is greater than 180 degree. Solution. True. D. The measure of an acute angle is less than 90 degree. Solution. True. Question 5. Fill in the blanks with acute, obtuse, right or straight. A. An angle whose measure is the sum of the measures of 2 right angles is dash. Solution. Straight. B. When the sum of the measures of 2 angles is that of a straight angle and if one of them is acute, then the other should be dash. Solution. Obtuse. C. An angle whose measure is greater than that of a right angle is dash. Solution. Obtuse. D. An angle whose measure is less than that of a right angle is dash. Solution. Acute. E. When the sum of the 2 measures of 2 angles is that of a right angle, then each one of them is dash. Solution. Acute. Question 6. A. Draw an acute angle of measure 45 degree with the help of a protractor. B. Draw an obtuse angle of 135 degree with the help of a protractor. Question 7. Which angle is larger? First, estimate and then measure. Measure of angle P is equals to 55 degree. Measure of angle Q is equals to 65 degree. Pair of lines. A pair of lines in a plane may be A. Parallel lines, B. Intersecting lines. A. Parallel lines. The figure given here shows two lines LM and PQ that never intersect each other at any point in the same plane. They are equidistant from each other at each and every point. This distance is called the distance between two parallel lines. Parallel lines LM and PQ are represented as LM parallel to PQ. Here symbol parallel is read as parallel to. B. Intersecting lines. In the figure given below, lines AB and CD intersect each other at a point O. Such lines are called intersecting lines. Facts to know. The angle of 50 degrees measurement on inner scale when angle is measured anti-clockwise. Exercise 10.5. Question 1. Give 3 examples from the environment for each of the following. A. Perpendicular lines. B. Parallel lines. C. Intersecting lines. Question 2. Study the diagram. The line L is the perpendicular to line M. A. Is CE is equals to EG? Solution. Yes. B. Does DE bisect CG? Solution. No. C. Identify any two line segments for which M is the perpendicular bisector of L. Solution. DE, CE, D. Are these true? First, AC is greater than FG. Solution. Yes. Second, CD is equals to EG. Solution. No. Third, BC is less than EG. Solution. Yes. Question 3. Write T for true and F for false for the following statement. A. Parallel lines meet each other at infinity. Solution. False. B. Intersecting lines never meet each other at any point. Solution. False. C. The symbol perpendicular is read as is perpendicular to. Solution. True. D. The symbol perpendicular is read as is parallel to. Solution. False. E. Perpendicular lines intersect each other at right angles. Solution. True. Question 4. Which of the following are models for perpendicular line? A. The adjacent edges of a tabletop. Solution. True. B. The line segments forming the letter L. Solution. True. C. The letter V. Solution. False. Question 5. There are two set squares in your box. What are the measure of the angles that are formed at their corners? Do they have any angle measure that is common? Solution. 60 degree, 90 degree, 30 degree and 45 degree, 90 degree, 45 degree. They have a common angle of 90 degree. Classification of triangles. A closed two-dimensional shape bounded by a straight line is called a polygon. The word polygon comes from a word Greek meaning many angles. A three-sided polygon is called a triangle. The sum of the three angles of the triangle is always equal to 180 degree. Triangles can be classified in two ways. First, by their sides. Second, by their angles. First, by their sides. Scalene triangle, isosceles triangle, equilateral triangle. Scalene triangle. A triangle having all three sides unequal is called scalene triangle. In figure given below, AB is not equal to BC is not equal to CA. So, triangle ABC is a scalene triangle. Isosceles triangle. A triangle which has two sides of equal length is called isosceles triangle. PR is equals to PQ is equals to 4 cm. So, triangle PQR is an isosceles triangle. Equilateral triangle. A triangle having all the three sides equal is called equilateral triangle. In the figure given below, LM equals to MN equals to LN equals to 4 cm. So triangle LMN is an equilateral triangle. Second, by their angles. Acute angled triangle, right angle triangle, obtuse angle triangle, equiangular triangle, acute angle triangle. If in a triangle each angle is less than 90 degree, then the triangle is called acute angle triangle. In the triangle shown here, angle L, angle M and angle N are all less than 90 degree. Hence triangle LMN is an acute angle triangle. Right angle triangle. If in a triangle any one angle is a right angle, one angle is 90 degree, then the triangle is called right angle triangle or simply right angle. This side opposite the right angle is called hypotenuse. DF is the hypotenuse. Triangle DEF shown here, a right angle triangle has angle equals to 90 degree. Facts to know: the sum of three angles in triangle is always 180 degree. Obtuse angled triangle. If in a triangle any one angle is an obtuse angle more than 90 degree, then the triangle is called obtuse angle triangle. In triangle PQR, angle P is an obtuse angle, so triangle PQR is called obtuse angled triangle. Equiangular triangle. If in a triangle all the three angles are equal, then that triangle is called equiangular triangle. An equiangular triangle is also called equilateral triangle because all of its sides are equal. Triangle XYZ is an equiangular triangle because in triangle XYZ, angle X equals to angle Y equals to angle Z is equals to 60 degree. Facts to know: a right angle triangle may be either isosceles. Exercise 10.6. Question 1. Define the following. A. Triangle. Solution. A three-sides polygon is called a triangle. The sum of the three angles of a triangle is always 180 degree. B. Scalene triangle. Solution. A triangle having all three sides unequal is called scalene triangle. C. Right angled triangle. If any one angle in a triangle is a right angle, then the triangle is called right angled triangle. D. Equilateral triangle. An triangle having all the three sides equal in length is called equilateral triangle. E. Isosceles triangle. A triangle which has two sides of equal length is called isosceles triangle. Question 2. The length of sides of a triangle is given below. Classify them as scalene, equilateral or isosceles triangle. A. 8.7 cm, 7.2 cm, 11.1 cm. Solution. Scalene. B. 3 cm, 5 cm, 8 cm. Solution. Scalene. C. 4 cm, 4 cm, 4 cm. Solution. Equilateral. D. 3 cm, 6 cm, 3 cm. Solution. Isosceles. E. 7 cm, 7.5 cm, 7.5 cm. Isosceles. F. 5.3 cm, 5.3 cm, 5.3 cm. Solution. Equilateral triangle. G. 2.3 cm, 3.3 cm, 3.8 cm. Solution. Scalene triangle. H. 3.8 cm, 4.8 cm, 3.8 cm. Solution. Isosceles. Question 3. The two angles of a triangle are given below. A 60 degree, B 65 degree, C is equals to 55 degree. B. P 45 degree, Q 90 degree, R equals to 45 degree. C. D 35 degree, E 135 degree, F equals to 10 degree. D. X equals to 53 degree, Y 42 degree, Z 85 degree. E. P 60 degree, Q 60 degree, R 60 degree. F. A 55 degree, B 65 degree, C. 60 degree. Question 4. Look at the measures of the triangle and name their types. A. Triangle ABC with M. Angle B equals to 90 degree. AB equals to 6 cm and BC equals to 4 cm. Solution. Right angled triangle. B. Triangle XYZ with M. Angle Y equals to 60 degree and XY equals to YZ. Solution. Isosceles acute angle triangle. C. Triangle with length of side 7 cm, 8 cm and 9 cm. Solution. Scalene triangle. D. Triangle ABC with AB equals to 9.7 cm, AC equals to 5 cm and BC equals to 4 cm. Solution. Scalene triangle. E. Triangle PQR such that PQ equals to QR equals to RP equals to 6 cm. Solution. Equilateral triangle. Question 5. Match the column A with column B. Column A, column B. First, one right angle with two sides of equal length to F, isosceles right angled. Second, three sides of equal length to E, equilateral. Third, one right angle to B, right angled. Fourth, three sides are of different length to G, scalene. Fifth, three acute angles to A, acute angled. Sixth, two sides of equal length to C, isosceles. Seventh, one obtuse angle to D, obtuse angled. Quadrilaterals. The figure is enclosed by four sides is called a quadrilateral. We can say that a quadrilateral is a polygon which has four sides. The sum of the angles of a quadrilateral is 360 degree. Let us learn about the types of quadrilateral and its properties. Types of quadrilaterals. Quadrilaterals can be divided into three parts. 1. Kite. 2. Trapezium. 3. Parallelogram. Parallelogram. A quadrilateral in which the pairs of opposite sides are parallel is called parallelogram. In the parallelogram A, B, C, D, the opposite sides are parallel. AB is parallel to CD and AD is parallel to BC. The opposite sides are equal. AB equals to CD and AD equals to BC. The opposite angles are equal. Angle A equals to angle C and angle B equals to angle D. The diagonals bisect each other. AO equals to OC, BO equals to OD. The diagonal divides the parallelogram into two equal triangles. The diagonal AC divides the parallelogram into two triangles, ABC and ACD. The diagonal BD divides the parallelogram into two triangles, ABD and BCD. Rectangle. Parallelogram. A quadrilateral in which each angle is a right angle is called rectangle. In rectangle ABCD, the opposite sides are parallel. AB is parallel to CD and AD is parallel to BC. The opposite sides are equal. AB is equals to CD and AD equals to BC. All angles are equal and measure 90 degree. Angle A is equals to angle B is equals to angle C is equals to angle D is equals to 90 degree. The diagonals are equal. AC is equals to BD. The diagonals bisect each other. AO equals to OC is equals to OB is equals to OD. Since AC is equals to BD. Rhombus. Parallelogram. A quadrilateral in which all four sides are equal is called a rhombus. In the rhombus ABCD, all sides are equal. AB is equals to BC is equals to CD is equals to DA. The opposite sides are parallel. AB is parallel to CD and AD is parallel to BC. The opposite angles are equal. Angle A is equals to angle C and angle B is equals to angle D. The diagonals bisect each other. AO is equals to OC and OB is equals to OD. The diagonals are perpendicular to each other. Angle AOB equals to angle BOC is equals to angle COD is equals to angle AOD is equals to 90 degree. Facts to know. A polygon does not have a curve in it. Square. Parallelogram. A quadrilateral in which all sides are equal and every angle is a right angle is called a square. In the square ABCD, all sides are equal. AB is equals to BC is equals to CD is equals to DA. Opposite sides are parallel. AB is parallel to CD and AD is parallel to BC. All angles are equal and measure 90 degree each. So, angle A is equals to angle B is equals to angle C is equals to angle D is equals to 90 degree. The diagonals bisect each other. AO equals to OC is equals to OB is equals to OD. The diagonals are perpendicular to each other and equal. Trapezium. A quadrilateral in which one pair of opposite sides is parallel is called a trapezium. In the trapezium ABCD, a pair of opposite sides is parallel. The opposite sides are not equal. The opposite angles are not equal. The diagonals are not equal. Kite. A quadrilateral in which both pairs of adjacent sides are equal is called kite. Exercise 10.7. Question 1. Give reasons for the following. A. A square can be thought of as a special rhombus. Solution. Because all the sides are equal. B. A rectangle can be thought of as special parallelogram. Solution. Because opposite sides are equal. C. A square can be thought of as a special rectangle. Solution. Because all the angles are 90 degree. D. Squares, rectangles, parallelograms are all quadrilaterals. Solution. Because these all have four sides. E. Square is also a parallelogram. Solution. Because it has pairs of two parallel. Question 2. Write T for true and F for false for the following statement. A. Each angle of a rectangle is a right angle. Solution. True. B. All the sides of a parallelogram are of equal length. Solution. False. C. The diagonals of a square are perpendicular to one another. Solution. True. D. All the sides of a rhombus are of equal length. Solution. True. E. The opposite sides of a trapezium are parallel. Solution. False. F. The opposite sides of a rectangle equal in length. Solution. True. Polygons. A polygon does not have a curve in it. A polygon is a plane figure that is made by joining the line segment, where each line segment meets exactly two other line segments. The intersection points of two line segments is called the vertex of the polygon. So far, we have studied about triangles, three-sided figures, and quadrilaterals, four-sided figures. We now try to extend the idea of polygon to figures with more number of sides. We may classify polygons according to the number of their sides. Number of sides. Name, illustration. 3. Triangle. 4. Quadrilateral. 5. Pentagon. 6. Hexagon. 7. Heptagon. 8. Octagon. 9. Nonagon. Exercise 10.8. Question 1. Classify the following polygons according to the number of sides. Solution. A. Pentagon. B. Quadrilateral. C. Hexagon. D. Pentagon. E. Octagon. F. Heptagon. G. Nonagon. H. Hexagon. Question 2. Which one of the following closed plane figure are not polygons? Solution. A. C. D. F. H. K. Question 3. Examine whether the following are polygons. If any one among them is not, say why. Solution. A. A circle is not a polygon because it does not have straight sides. B. It is not a polygon because it is not a closed figure. C. It is a polygon. D. It is not a polygon because it has a curved line. Question 4. Name each polygon. Solution. Pentagon. B. Square. C. Quadrilateral. D. Trapezium. Points to remember. A circle is not a polygon as it does not have straight sides. An angle whose measure is more than 0 degree but less than 90 degree is called acute angle. An obtuse angle is greater than 1/4 of a revolution but less than half a revolution. The angles which have measure more than 180 degree but less than 360 degree is called reflex angle. When two lines intersect and the angle between them is a straight angle, then the lines are said to be perpendicular. The points that never intersect each other at any point in a same plane is called parallel lines. A triangle having all three sides unequal is called scalene triangle. A triangle having all the three sides equal is called quadrilateral triangle. If in a triangle each angle is less than 90 degree, then the triangle is called acute angle triangle. Triangles can be classified as follows based on the length of their sides. Nature of sides in the triangle. Name. All the three sides are of unequal length. Scalene triangle. Any two of the sides are of equal length. Isosceles triangle. All the three sides are of equal length. Quadrilateral triangle. Quadrilaterals are further classified with reference to their properties. Properties. Name of the quadrilateral. Parallelogram with 4 right angles. Rectangle. A rhombus with 4 sides of equal length. Parallelogram. 1 pair of parallel sides. Trapezium. 2 pair of parallel sides. Parallelogram. Parallelogram with 4 right angles. Rectangle. Exercise. Question 1. Multiple choice question. MCQs. Tick the correct options. A. A triangle with all its angles equal to 60 degree is first, scalene, second, quadrilateral, third, isosceles, fourth, right. Solution. Second, quadrilateral. B. Where will the hour hand of a clock stop if it is from 10 and turns through 3 right angles? First, 4, second, 2, third, 7, fourth, 8. Solution. Third, 7. C. If two angles of a triangle are 70 degree and 45 degree, what is the measure of the third angle? First, 35 degree, second, 65 degree, third, 45 degree, fourth, 70 degree. Solution. Second, 65 degree. D. When two angles of a triangle are same, the third angle will be first, the same, second, different, third, dependent on size, fourth, dependent on angle. Solution. Fourth, dependent on angle. E. If three angles of a quadrilateral are 100 degree, 80 degree and 70 degree, what is the measure of the fourth angle? First, 100 degree, second, 105 degree, third, 120 degree, fourth, 110 degree. Solution. Fourth, 110 degree. F. A scalene triangle has first, two angles equal, second, all angles equal, third, no two angles equal, fourth, none of these. Solution. Fourth, none of these. G. Two angles of a triangle are 135 degree and 35 degree. Third angle will be first, 60 degree, second, 10 degree, third, 75 degree, fourth, 235 degree. Solution. Second, 10 degree. H. How many right angles do you make if you start facing west and turn clockwise to face east? First, 4, second, 2, third, 3, fourth, 1. Solution. Second. Question 2. How many line segments can you find in the column figures? Write them. Question 3. Classify the following angles as acute, obtuse and reflex angles. A. 35 degree, acute. B. 118 degree, obtuse. C. 325 degree, reflex. D. 150 degree, obtuse. E. 221 degree, reflex. F. 300 degree, reflex. G. 48 degree, acute. H. 125 degree, obtuse. I. 145 degree, obtuse. J. 92 degree, obtuse. K. 85 degree, acute, L 30 degree, reflex. Question 4. The two angles of a triangle have been given, then find out the third angle. A 60 degree, B 75 degree, C 45 degree. B. P equals to 45 degree, Q 90 degree, R 45 degree. C. X 90 degree, Y 25 degree, Z 65 degree. D. A 55 degree, B 65 degree, C 60 degree. E. P 53 degree, Q 80 degree, R 47 degree. Question 5. Look at the measures of the triangles and name their types. A. Triangle PQR with M, angle Q is 90 degree, PQ equals to 6 cm and QR equals to 4 cm. Solution. Right angle triangle. B. Triangle XYZ with M, angle Y equals to 60 degree and XY equals to YZ. Solution. Isosceles acute angled triangle. C. Triangle ABC with AB equals to 6.9 cm, AC equals to 5 cm and BC equals to 4.2 cm. Solution. Scalene triangle. D. Triangle with length of side 6 cm, 7.9 cm and 8.3 cm. Solution. Scalene triangle. E. Triangle PQR such that PQ equals to QR equals to RP equals to 5.5 cm. Equilateral triangle. Lab activity 1. Place a pair of unequal sticks such that they have their endpoints joined at one end. Now place another such pair meeting the free ends of the first pair. What is the figure enclosed? It is a quadrilateral like the one you see here. The sides of the quadrilateral are PQ, QR. There are 4 angles for this quadrilateral. They are given by angle SPQ, angle PQR, angle QRS and QS is one diagonal. What is the other? Measure the length of the sides and the diagonal. Measure all the angles also. 2. You have 2 set squares in your instrument box. One is 30 degree, 60 degree, 90 degree set square. The other is 45 degree, minus 45 degree, minus 90 degree set square. You and your friend can jointly do this. A. Both of you will have a pair of 30 degree, 60 degree, 90 degree set squares. Place them as shown in the figure. Can you name the quadrilateral described? What is the measure of each of its angle? This quadrilateral is a rectangle. One more obvious property of the rectangle you can see is that opposite sides are of equal length. What other properties can you find? B. If you use a pair of 45 degree, 45 degree, 90 degree set squares, you get another quadrilateral this time. It is a square. You are able to see that all the sides are of equal length. What can you say about the angles and the diagonals? Try to find a few more properties of the square. C. If you place the pair of 30 degree, 60 degree, 90 degree set square in a different position, you get a parallelogram. Do you notice that the opposite sides are parallel? Are the opposite sides equal? Are the diagonal equal? D. If you use several set squares, you can build a shape like the one given here. Here is the quadrilateral in which 2 sides are parallel. It is a trapezium. E. Here is one outline summary of your findings. Fill up the boxes. Quadrilateral. Opposite sides parallel, equal. All sides equal. Opposite angle equal. Diagonals equal, perpendicular. Parallelogram. Yes, no. Yes, no. Rectangle. No. Square. No. Rhombus. Trapezium. No.